side revision. We're doing 1 and 2D calculations, and here is our first contextual question. It says Mr. Fenter bought a farm, and he's trying to sell chickens and vegetables, and below is the layout plan of the farm. Now, this is not map work. It is measurement. All right, we're just seeing a diagram here of the farm. So we've got all kinds of different sections of the farm. We've got perennial garden beds over here at the bottom right-hand side. We've got a greenhouse in the middle. We've got a vegetable garden, solar greenhouse, a livestock barn, a chicken site. And then on the left here, we've got a garden expansion with a whole lot of dimensions on it. Obviously, they're going to ask us questions on that, on the garden expansion. All right. And we've got little circles with J in them. These are apparently JoJo tanks, but we're not really going to answer many questions on this. There were, I've removed some questions on this contextual diagram that were very, very easy. You guys would have easily got your 2 marks for those. But we're going to dive into the meaty questions for this diagram here. So let's see what they're going to ask us. There's the first question there. It says, calculate in meters squared the area of the garden expansion. Calculate in meters squared. There at the bottom is the question. The area of the garden expansion. So here's the garden expansion over here. All right. And they want us to calculate in meters squared the area of that garden expansion. All right. I need someone now. There is a formula. I know what you're thinking. Show us the formula. Yes, they give us the formula. They say use the following formula. But I want to see if anyone knows what formula we'll use for the area of this garden expansion. Don't worry, Maria. We just got started. Can anyone tell me what is the formula for the area of this garden expansion? What formula will we use? Yes, it is down there. I'm going to show it to you. I'm just interested to know. Don't worry, Dilshad, don't worry. The area of this shape here. There we go, Khabo, well done. There's the half times base times height, because this is a triangle. Yes, there we go, well done, good job. Well done, Nomprolelo. Half times base times perpendicular height, okay, because it's a triangle. Okay, so there we go. There's the formula at the bottom. You may use the following formula. They give it to you. Area of a triangle equals half times base times height. Now, you just have to know what goes where. Okay. So I need someone to come here online and tell me I've got 4 dimensions on this diagram. Which one goes where? There's the formula. All right. There's Ben.
Hi, sir.
Hi, Ben. How you doing?
I'm fine, thanks. And
I'm good, thank you. You finished your exams a while back, hey?
yeah, I finished my maths. I'm still writing.
Okay. When do you finish? The end of this week?
I finish next week Wednesday.
Sure. Okay. All right. Still got a little bit to go. Are you feeling tired?
Yes, yes, I am.
Yeah, I can imagine, eh? All right, Ben, help me out here. Which dimensions go where here?
It would be 21,28 meters times 0.04 meters.
21,28 times, you said?
Oh, the height, which is 19,5.
Okay, good. So you said height. All right, so I'm going to highlight that one there. So you said height, okay, which is this one here. All right. So that's the height taken care of. And the base, B for the base of the triangle. Where's the base of the triangle?
17,024.
Yeah, good. So this one here is the base. Okay, there's our base over there. Good. So there's B for base. All right. So the height is actually a perpendicular height. This height must come off at 90 degrees from the base. So the height that they have in a triangle must come off the base. So that's the height we're talking about. All those other numbers are just there to try and confuse you. So the base is 17,024 meters. And then I'm going to put in my height, just move over a little bit here, times 19,5 meters. All right. I'll put that into our calculator. So it's 17,024 times 19,5. All right, 331.
Yes.
331,968. You happy with that?
Yes.
And the units are meters squared, and then we'll round this off to 97. All right, cool. Thank
So
you,
you
Ben.
didn't put the half. You didn't put the half.
Oh, let's go back. Let's put in a half. Sorry. It's been a long day. All right, so 0.5 times. There we go. There we go. 165,984. 165,984.
Yes.
All right, 165,984. That'll round off to 165,98. You good with that, Ben?
Yes, yes, so that's fine.
Awesome. Thank you very much, Ben. Thank you very much. Okay. There are a couple of other questions here. Sofiso.
Good day, sir.
Sofiso, you well?
I'm good, thanks. Yourself?
Good, thank you. What can I do for
So
you?
can I please ask, sir, what if instead of like writing half, you just like divided the base by 2, and then it gives you like 8,512, and
Let's
then you
try that.
times that by the height.
Let's try it. Should work. Let's try it out. So I'm going to take the half away there. And I think I can do it like this. There we go.
And then
Divide that
by 2.
Yeah, that's fine.
Oh, is it fine? Do we
Yeah.
still get the same marks and stuff?
Yeah.
Okay.
You should get the same marks. The marker is gonna have to look for it and pick it up.
Yes, sir.
You should get the same marks. Now, I don't think it's going to be a train smash if you do it like this, because all you've done is multiply the half by the first number in the formula, which is exactly fine. That gives you 17,024 divided by 2. So you've just joined the first 2 and then you're multiplying by the third one. That's fine. They should give you
Okay.
marks for that. No problem.
Okay, thank you, sir.
All right. Okay. Let's move on. Got a couple of marks in the bag. Just checking now. They wanted meters squared. They wanted meters squared. We gave them meters squared. We give them what we want. Yes. All right, cool. Let's move on. So that is the answer for the first one. Okay. Yeah, let's move on to the second one. Mr. Fencer, still the same farmer, decides to replace the fence around the circular chicken site. The circumference of the circular site is 18,852. So up here, there's a circular chicken site. You can see it there next to the livestock barn. He decides to put a fence around that. They tell us the circumference of the circular site is 18,852. All right. Now, we've got 2 cost options for the wire mesh. We've got option A, which is 1,154 Rand for a 10-meter roll. And we've got option B, which is 127 Rand 30 per running meter, which just means per meter. All right, those are our 2 options. It says here, by means of calculations, advise Mr. Fenter which option is more economical. When they say economical, that obviously means which one costs less. All right, who is keen to try this one out? Okay, I'm going to bring in fact, it's right over there. There's a circumference. There are 2 options. Who would like to try this one out? Anybody? Anybody out there? Somebody to help me. Anybody? Oh, it's crickets. All right, there we go, Manuel.
Good afternoon, sir.
Good afternoon. Don't you think I should make an album? Definitely making an album, hey?
Yes, sir. Anybody.
Anybody?
Need your help. So I actually have a question on the last.
Sure.
Wait, where are my manners? How are you, sir?
I'm good, Emmanuel. How are you?
I'm good, thank you. So on this one, why was it not supposed to be cubic meters or meters
No,
cubed?
no,
Because
the question at the bottom said meters squared and it's area. Area is always meters squared because we're timesing two one dimension. Oh, so I see why you're saying that, because there's a meter squared there. That's why you're confused. All right, so
yes, sir.
if you multiply meters by meters, you should get meter squared. That's why there's
Meter squared,
confusion.
yes, sir.
Yeah. Oh, thanks, Emmanuel.
Thank you.
Yes,
Thank you,
meter
sir.
squared. Meter times meters is meters squared. Emmanuel, why are you here? Don't you want to help me with this one? All right.
Okay,
Let's try.
so
Let's try it.
let's
So
tackle it. Let's tackle it.
let's tackle this one.
It says Mr. Fenter decides to replace the fence around the circular chicken side. The circumference of the circular side is 18,42. Okay, two cost options for your wire mesh. Option A is okay, sir. I
Yeah.
think what we have to do first is check how much each option costs. So
All right.
if it's 18,52, let me write it down, 18,852
Two.
meters. And for option A, it's going to cost you 1,154 rand for a 10-meter roll. It means that what you're gonna have to do is gonna take the 18,852 and divide it by the 10 meters and multiply it by 1,154 rand.
Okay, you got to be careful with this one, because you can only buy this fence in a 10-meter roll. You can't buy anything less than a 10-meter roll. So what you should ask is, if he needs roughly 18.8 meters, how many 10-meter rolls will he need?
2.
You will need 2. So we're going to say 2 of those 10-meter rolls, and each one is
times 1,154, which should give you 2,308, sir.
All right, 2,308 rands. Okay, that's option A. So that's how much it'll cost. Option B is easier. What do we do there? It's 127.30 per meter.
So that one, you're just going to have to multiply it by 18,852.
That's it. So 127.3. 18.852 times 127.3. 2399, comma 8596 8596. I'm just going to round this one off to 2399, comma 86. All right, there we go. So the question says, by means of calculations, advise Mr. Fenter which option is more economical. So which one is more economical, Emmanuel?
Option A, sir.
Option A is the
yes.
In this scenario, option A will be better. Now, it could change if this wasn't 18.8. If this was like 21,3 meters, he would have to buy 3 rolls and have a lot of extra. And then maybe option B would be better. But right now, we're sitting with 18.8 meters that he needs. Buying the 2 10-meter rolls is better for him. Emmanuel, thank you so much for your help. All right, so there's 2 options here. We've got A, we needed 2 rolls because he's got 18 meters of fence. All right, and they only come in a 10-meter roll, so he has to buy 2. He needs 20. All right, you can't buy 1, it won't be enough. If he buys 2, he'll have 20 meters, which is enough. Okay, and then you times 2 by 1,154 to get your overall price for that. Option B is just per meter, so it's 18.852 meters times 127 rand 30. Now, some people might argue and say, so he's going to have leftover. Is it really economical? You're right. There is a little bit of fence left over. Okay, if you were really, really, really nitpicking, you could actually work out how much that a little bit of fence is, All right, because you could actually say 1154 divided by 10, and that'll give you a price per meter. It's 115 Rand per meter, and work out exactly how much fence he's got left over. He's wasted 100 odd Rand of fencing. Is it economical? Okay, but don't worry, Otlile, no problem. I don't think the question is heading towards that. I think the question is just do two calculations, compare the two, which one is the best one, and we can see that option A is less, 2,300 versus 2,399. So option A at 2308 is better. All right, Emmanuel, thank you so much for that. Let's move on. Guys, I've got such a, where is 2 coming from? 2, Bianca, I think you're talking about the 2 here at the top. So it says here that it's a 10-meter roll for option A. So you have to buy it in a 10-meter roll. And I've done this often. You go to Builder's Warehouse, you want a piece of wood. And you say, listen, I need 2.1 meters of this wood. And they say, sorry, we only sell them in 3-meter lengths. They won't cut it down to 2.1 meters for you. You have to buy the whole length. All right, so it's the same thing here. It's a 10-meter roll. You have to buy it in 10-meter rolls. So he's going to need 2 to cover his 18 meters. All right, so 2 10 meters is 20. So 2 will be enough. 1 is not enough. 3 is way too much. 2 is just right. So that's why we multiplied 1,154 by 2. And they gave us a price of 2308. The other one was easy. It's just per meter. So we just multiplied our meters by the per meter price. They gave us 2399.86, which is a little bit more expensive. All right. Okay, guys, I've got a big one at the end there. Hopefully we can get to it. You know what I'm like? I like to keep the deep, dark, meaty questions at the end. Let's see if we can get to it. All right, here we go. One of the JoJo tanks in this farm has a capacity of 5,000 liters. The height of the tank is 220 centimeters. Calculate in centimeters the radius of the tank. You may use the following formula. Now, let's do this. All right, let's draw us a little tank. Okay, so we're drawing a little JoJo tank here. All right, so there's our JoJo tank. Okay, and they say that the height of the tank is 220 centimeters. All right, and its capacity, all right, its capacity is 5,000 liters. Where on earth do we even start with this? They want to know, what is the radius? Yikes. Who's got an idea? Who's got an idea? There's all the information. 5,000 liter capacity, 220 centimeters high. They give us all that information. They also give us this conversion. That's probably going to be needed. And they give us the formula for volume of a tank. Guys, what do I do? Anybody got an idea? Ben?
So you would basically put all the numbers that are given to you, and then you would shift it one side and divide it.
Very
and
good.
You
So
would get the radius.
very good. So Ben's suggesting that we fill the formula. All right. We fill the formula with all the things that it needs. I'm going to write the formula out in a more simple form. So V is equal to 3,142. We know that's the pi number times radius squared times height. Okay. So Ben is suggesting that we fill all these things in. We give it the volume and we give it the height, and then out will come the radius if we change this formula or this equation around a little bit. Okay. Ben, you still there, eh?
Yes.
Okay. So which one do we start with first, the volume or the height?
The volume.
Okay. So what is the volume of this tank?
It says that it's 5,000 liters, but if you convert it, it would still be 5,000 centimeters cubed.
So they say one in the conversion, yeah, they say 1 liter is 1,000 centimeters cubed. We don't have 1 liter, we've got 5,000 liters. So what do I need to do with that 5,000?
So you would times it by 1,000.
Very good. So if every 1 liter is 1,000 centimeters cubed, and I've got 5,000 of them, of these liters, I've got to multiply each one of them by 1,000. And this is going to give me a huge number.
Yeah, we'll give you 5 million.
1, 2, 3, 4, 5, 6, 5 million. All right. So 5 million centimeters cubed. So the first thing we did was change to centimeters cubed. Why are we doing this? Because our height is in centimeters cubed. Okay. Now, and also the radius they want, look at the question, is also needing to be in centimeters. So the units we have to work in here are centimeters. This is why Ben's suggesting we do this. So we're changing everything to centimeters. Okay. So I don't have to change the height of the tank. I need it in centimeters. Now, this volume is ready to go into the formula. So like Ben suggested, I need to put this volume into the formula over here on the left, because this is where the V is in our formula. All right. V for volume is 5 million centimeters cubed, and that must equal 3,142 times R squared times, and the height comes straight from the diagram there. It's 220 centimeters. Okay, so we got to make sure that our units are the same. We got centimeters there. We got centimeters there. So our radius will come out in centimeters. Okay, Ben, this is the interesting part. What do I do now?
You on your right hand side, you times 3,142. You times it by 220.
So yes, what Ben's doing is saying, so simplify the left-hand side of this equation. Make it more simple. All right, so the 5 million centimeters cubed, he's saying put these two numbers together, multiply them together. So that's what we're going to do.
Yeah.
So you're going to say 3,142 times 220, and that gives us 69124. So that's 691,24. But we still have the times R squared. All right, Ben?
Yes.
Now what?
You would shift the 691,24 on the other side, and you would divide it by 5 million.
Yes. So Ben is suggesting to get rid of the 69124 on the right-hand side, we've got to divide. Why is he saying divide? Because this 691,24 is attached to our radius, the thing we're trying to find. It's attached to it with times. So we will do the opposite operation or the inverse operation. So we will have to get rid of it. We'll have to pry it off and flick it off by doing the inverse operation. So the inverse of multiply is divide. So 691,24. Divide that. But what you do on the right-hand side, you also got to do on the left-hand side. Okay. So dividing by 691,24 there and there cancels it off on the right-hand side. That's what we want. So now what we're left with is, oh, I'm needing lots of space for this one. Let's get some more space here. Okay, so we've got R squared left on its own now. We've got rid of that number, and we've got 5 million divided by 691,24. So let's find out what that is. So 5 million divided by
7,233,377.
all right, so 7233,377. So 7233,377.6. I think I'm writing 4 decimals. You could write them all, but the 4 decimals should be enough for this. All right, Ben, what do I do now?
You'd round it off, so it'd be 7233,38.
Okay,
And that's
so
the radius.
okay, but careful, this radius has still got a power of 2 on it, hey? We've got to get that thing, we've got to get rid of that power of 2. So what's the inverse of the power of 2?
Is now square root.
Yes, it's the square root. So the square root and the power of 2 cancel each other out. But what you do on the right-hand side, you got to do on the left-hand side. And I know what you're all thinking. This is not Mathlit anymore. This is changed to Cormat. No, it's not. It's just math operations. We use math operations in math literacy. It's fine. So we're using the square root to get rid of the square, okay? If it was r cubed, you would use the cube root, but you don't often see that in math literacy, but it's the same idea, okay? So now r is by itself. So we've got to take this value, oopsie, and we've got to square root it. So I'm using the square root button. So 7233.3776. I haven't rounded it off yet. There we go. 85,0492. 85,0492 centimeters. Remember, if we put in the centimeters will come out. What you put in is what you get out in an equation. All right, let me just make some more space. Yo, it's quite a long one. So R rounded off. Ben, just check I'm good here. So 85,05 centimeters.
Yeah. Yes.
All right. Ben, excellent. Well done for seeing exactly what you need to do there. Good job.
You're welcome.
All right. Are there any questions about this one? It is quite a long one because we're going through it step by step. Are there any questions about this one here? All right. So let me just go over it one more time. We got given the formula, okay, and they asked us to find the radius, okay? So you write the formula out like I did over here. Write the formula out and look at it and see, that's what I want, the radius. So if I put in all the other numbers like the height and the volume, I can get radius out. They don't give you the volume exactly like you need it for this equation. You had to change the volume from capacity into volumetric units. So from liters to centimeters cubed. You can't put liters in here, all right, and expect to get centimeters out. You have to put centimeters in to get centimeters out. Okay, so we had to change the volume to centimeters cubed. All right, and then we put it in, and then we started isolating this radius. First, Ben said, join the numbers up to make one number, 691,24, then divide by the 691,24. We're left with the r squared, square root it, square root both sides. Remember, what you do on the one side, you got to do on the other side. Okay, a rule for equations. All right, well done. Good job. No questions? If there's no questions, I assume we're all good. Hope we're all good. Hope we're all good. All right, we're going to take a little break. Take a little break. Who's finishing this week and who's finishing next week? You are looking at someone who's very happily finishing this week. Who's finishing next week? Emily, are you finishing next week? Yes, next week as well. Emily's finishing next week. Well, how about you finishing next week or this week? Where's Tristan? I can see Tristan's floor. Tristan Bull's floor. I think Tristan's finished. He's fallen flat on the floor already. Who else is finished? Oh, here we go. There we go. There we go. I'm finished tomorrow writing maths. Your stress, Otlile. Oh, I'm sorry, man. I'm sorry, Otlile. Hang in there. Hang in there. You're almost done. Well done. Emily's this week. Somlele is next week. Havila is this week. Yes. Mohammed this week. Zuko next week. Fatima this week, next week. We are finishing tomorrow. Dilshot, you're finishing. Oh, you're finishing your exams tomorrow. Okay, I'm finishing next week, this week. All right. So yeah, it's a bit of, it was like 50-50. Oh, Tundo. So this is perfect timing then, hey? Business. Oh, it's a horrible one to finish on. Writing maths on Thursday, last one. What? They make maths the last one. The Timber, that's not very nice at all. Why do they do that? Maths for the last one. Maths should be up front or in the middle somewhere, not at the end. Should end with LO or history. That's fine. You can finish an LO in history, not maths. Yo, that's not very nice of them at all. Sheesh. That's harsh. Oh my gosh. Also finishing with maths. Isivile. I was like, please not history. Okay, not history, geography. All right, how about geography? Writing maths on Thursday, Fatima. All right, good luck for that, hey. So we're still in the middle of it, guys. Still in the thick of it. Some finishing this week, some finishing next week. I hope you guys do very, very well. Geography. Oh, geography is easy. We do geography in Mathlet. It's easy. Just map work. Come on, what's geography? All right. Let's see what else we've got here. Let's see if we can next Friday. That's tough. I remember the days when schools used to finish all the way up to the last day of school. And you walk out of there with a huge relief. Last exam, last day, term done, finished. What a feeling. All right. There's our break. Let's have a look at the next question. All right, we got an American flag, got some color in our question tonight. Luanda bought an American flag mounted on a rectangular wooden frame shown in the diagram below. All right, so we got the American flag on the left there. And this diagram here is also the American flag, but without the pattern. So this is the blue part, right? And this is the red part of the flag. Okay. So that's what they're trying to show you here. So the shapes that you have in the American flag are here in the diagram with dimensions on the left. I don't know if you guys can see all the dimensions in the diagram. We've got a width here without a dimension. We've got inches here. We've got centimeters there and centimeters there. It's very interesting. All right, here's the question at the bottom. Number one, state. Don't calculate, just state, just write it down. State if the width of section C of the flag is given in imperial units or metric units. The width of section C of the flag, is it in imperial units or metric units? Everyone should be typing in chat. The width of section C, is it in imperial or metric units? Everyone should be typing in chat now what the answer is for question one. You guys can see it there. Everybody should be giving me the answer for this. Imperial units or metric units. This dimension here. Imperial. Guys. This one here. The width, the shorter one. Not the long one. The shorter one. Is it imperial or metric? Yes, it's metric, guys. Metric, that's our one. Right, metric is the best. Don't worry, we're all tired. All right, metric is the best. So this one here in centimeters is a metric unit. The one at the bottom here for the length of section C is imperial, the American one. Okay. All right, so centimeters is metric, that's for us. And inches is imperial, that's for them. All right, let's see what question 2 says. So this is metric. Question 2 says, calculate the area in centimeters squared of section C of the flag. Give your answer correct to 1 decimal place. Who's going to help me with this? It's an easy one, guys. Well, it's easier compared to the one we just did. I need a formula. Do they give us a formula? Before I even show you if they give us a formula, you should be able to tell me what the formula is. How do we work out the area of section C? All right, Abo.
Hi, sir.
Hey, how are you?
I'm good. And you?
Good. What formula are we going to use here?
You're gonna use length times breadth.
Yes, area is equal to length times breadth. Okay. What do I? Okay, so I need a length. What should I do? Ooh, hold on. There we go.
You need to first convert it into centimeters.
Good. All right. So let's not even do that now. Let's convert straight away. So this 10,4. What do I do with that?
You times it by 2.54.
2.54. 10.4 times 2.54 gives us 26.416. 26.416 centimeters. Should I round this off?
Not yet.
Very good. All right. So now we can go to the formula, hey?
Yeah.
So
So then you
26
say, yeah.
multiplied by 18,796 centimeters. All right. And that should give us our answer. So 26.416 times 18.796. 18.79. Oops, 6. Are you happy with that answer?
Yes. And then you have to round it off.
Centimeters squared, because area is always squared units. So that's 4. Whoopsie. Let's do it like we usually do. So 496, comma 5.
1, 2, sorry.
2. All right, there we go. Habo, thank you very much. Awesome. This is a lot, not much for 5 marks, eh? Did you notice it's a 5-mark question? It's not much for 5 marks. So conversion, 2 marks there. Maybe subbing into the formula there, an answer and rounding off the answer. Ooh, I would have given maybe 4 marks for this. Anyway, we'll take 5 marks. We'll take it. Habo, thank you very much. All right, worked out the area. What else? Frame is 201,93. So, you guys still hear me? Real good? You're all good? You can all hear me? Good. All right. So they say calculate the width of the front view of the wooden frame if the perimeter of the frame is 201,93. All right. So I'm going to quickly draw the frame here, just a diagram. Okay. So if I go up to the top again, we've got 66,04. We've got 66,04 centimeters here. Okay. That's for the length. Then they're asking us, what is the width over here? What is this dimension over here? All right. If the perimeter is 201,93 centimeters, what is the width? They say use the following formula there. All right. Awesome. So we're just going to sub into this formula and see what we can do with it. So perimeter goes in the top of the formula there. So 201,93, they gave us the perimeter. So I'm putting it into the formula at perimeter, and I have to divide it by 2. And this is equal to length. I've got a length, it's 66,04 centimeters. And they say plus width. All right. So width is what I'm trying to find. Oh, the size of the same. Not in a rectangle. In a squared would be the same. But this is a rectangle. Let's check. Did they actually say it's a rectangle? Yeah. They say rectangle at the top here. So the sides don't have to be the same. If it was a square, that would be easy. But it's not a square, it's a rectangle. So we have to do it like this. All right, so we're getting back to one of these equations where we have to move things around. Okay, now I'm going to quickly work through this one because I want to get to this last question. All right, I'm going to do like Ben suggested the last time. This here, simplify it, make it more simple. All right, so let's do that now. So say 201,93 divided by 2. Let's go back. Divided by 2. That's 100,965. So it's 100,965. Okay, so I've just taken the top fraction and I've made it more simple. So now I've got 100,965 is equal to 66,04 plus W for width. Now to get rid of this 66,04 over here, what do I do? Right, well, it's attached to the W with a plus. So we will do the opposite of plus, which is minus, okay? So you can say minus 66,04, all right? But what you do to the right-hand side, you must do to the left. So I'm just going to write it at the bottom here. So it's minus 66,04. In fact, let me write it out properly. No, that's all right. Okay, so we're going to minus on both sides. Okay, now what happens now is these two will cancel each other out because 66,04 minus 66,04 is 0. That's what we want to do. Okay, so we're canceling it there on the right-hand side. And on the left, we have 100,965. I'll just write it out for you to see, minus 66,04. So the width is equal to all of that. So let's get it there and say minus 66,04 gives us 34.925. All right, 34.925. Yo, I'm running out of space tonight in a big way. These questions are long. 34.925, if I'm not mistaken, 34.925. 34.925 centimeters. All right, and I'm going to round it off to 34.93 centimeters. You all happy with that? Yes, you all happy with that? Please let me know if you're not happy with that. If you have any questions, let us know. Raise your hand. Use that function, raise your hand. I finally get to show you guys the hard question. I'm so used to running out of time. We don't get to see these things. Now we get to see one. All right, have a look at this, guys. The IM and CM were allocated. All right, don't worry who the IM and the CM were, but someone was allocated tables with semicircular shaped table tops, as shown in the picture below. So there's a diagram with a semicircular tabletop. Lumka, the center manager, explained that 2 semicircular tabletops are made from 1 square piece of wood. All right. Now we're reading over here the second paragraph. The information on how the semicircular tops are cut from the square piece of wood is in Annexure B. So here on the right-hand side here is Annexure B. I will show you that now. The dimensions of the wood are 2.7 meters by 2.7 meters with a thickness of 38 millimeters. All right. You may use the formula area of a square equals side times side. So this is the diagram to show how they measure and cut out the tabletops. Okay. So step number 1 is you get a square piece of wood. Step number 2 is you draw that shape on the wood. Now, please don't fret about the gap in the middle. Okay. Please don't worry about that. So step number 2, you got to draw the shape of the wood. Step number 3, that's what it looks like when one of those semicircles is cut out and you've got dimensions there, and they say, guys, the drawing is not to scale. Just be careful. And then here, step number 4 is what it looks like when you have 2 of these tabletops next to each other. Okay, I hope you understand. So square piece, draw some circles on it, cut them out, and you get these semicircular shapes. Okay, so that's what why this table looks like it does on the left-hand side here. So the semicircle shape like that comes from this method. All right, here we go. Matrix, are you ready? Grade 11s even, grade 10s. Yee. Now, good news is we don't have to worry about the volume. You don't need that. All right, we're going to stick with the basic stuff, okay? We're not doing volume tonight. So we've got area of a square given to us, and we've got area of a semicircle given to us. Now, please remember, a semicircle is half of a circle. All right. It's not the best looking semicircle, but that's a semicircle, half a circle. Okay. So that's the area of half a circle. Here's the question. Lunker stated that 2.01 meters squared of the wood is cut off when making 2 semicircular shaped tabletops from 1 piece of wood. Verify showing calculations whether the statement is valid. 8 marks. Let's read it again. He says that this amount of wood is cut off when making these shapes. So when you see this diagram here, right, look at step number 2. Okay. It's all this stuff here. It's all this stuff on the outside. That wood there. That's what they're talking about, right? They say, Lumka stated that 2.01 square meters of the wood is cut off when making these tabletops from 1 piece of wood. show if this is correct. All right. So what we need to do is work out this shaded part that I've shaded here. What is its area? Guys, what do I do? Yeah, pi r squared for a circle, and then you cut it at half. You're right, Tana. So this top part here is for a circle, pi times r squared, and then you divide it by 2 and cut it in half for a semicircle. Okay. Now, who would like to try this one? Oh, guys, so that shaded black area there, what is its area? How am I going to find that? Can anybody hazard a guess? Can anybody hazard a guess? How are we going to find that? There's quite a lot to this. It's 8 marks. I knew Khabo was going to try this one out. Khabo loves a challenge.
So I'm just testing it. Like I'm not sure, but I'm just gonna try.
Mm.
Yeah. I think you have to work out the area of the whole piece of wood at first.
Yes,
And
let's do that. Let's do that. All right, so they say the area of a square is equal to side times side, so it's 2,7 times 2,7. All right, so let's quickly get that out. That's the area of the whole piece of wood, guys. We've got to do that first. Okay, so it's 7,29 square meters. So we've got 7,29 square meters of wood to start with. All right, how about what do I do now?
I think. Wait, please can you go back to the question, did you?
The bottom question or the scenario?
The scenario, sorry.
Scenario. All right, there we go.
Oh no, sorry, the question, my bad. Sorry.
Okay, there we go at the bottom. So what he says that 2,01 square meters of wood is cut off when you make these things.
Okay, so I think you have to minus that 2.01 from the answer.
What he's saying is, so this square, he says, when you take this square and you cut out, let me highlight it, see if I can highlight it here with a nice pink color. He says, when you cut out these semicircles here, and they put together, so it's like one big circle. He says, when you cut this shape out, you left with 2,01. So when you cut out that pink part, you're left with 2,01. Let's read the question again. It says, Lumka stated that 2,01 square meters of the wood is cut off. Or maybe they mean, I see what you're saying. I think cut off means almost like cut away. Otherwise, they would have said that it's 2,01. They would have said the tabletop, the area of the tabletop wood needed is 2,01. I think he stated that 2,0 of the wood is cut off when making these things. So I think that's what's left behind, eh?
Yeah, it's a circle. So I think you have to work out the area of a semicircle, and then first we'll work out the area of the semicircle.
Okay. Now, before we do the semicircle, I just want us to get a mental picture of what's required here. So we've got a square piece. All right, there's the white area. And we've got the pink area there, which is the wood of the tabletop. And they want to know what is the area of the white piece. So if I take the square piece and I minus the pink, I'm left with all the white that's left behind.
Yeah.
All right. So that's what we're trying to do. So if I take the square one and I minus the area of the pink, I should be left with this amount. Yes?
Yeah. Yes.
So we got to work out the area of this pink part here and then subtract it from the area of the square.
The square, yeah.
Okay, so now there's two shapes that you see here. I hope you guys can see it. Number one, I'll do this. There's a big circle, all right, on the outside. So I'm trying to show the outer circle first. So that red line is for the outer circle. Then you've got an inner circle. Okay, so we've got the inner circle over here. All right. Now, if this inner circle wasn't blank, then this would be a whole lot easier because we would say, oh, it's just work out the area of the whole circle and just subtract it from the square. But
Yeah.
it's not that easy. We can't remove the middle circle. So this middle circle outlined in blue has to stay. So we need to know what that middle blue one is, and then we need to know what if there was a big solid red one or pink one. You with me?
Yes.
Okay, so we don't want to cut out the middle part. We just want to remove the pink. So I suggest we work out the area of the middle part and keep that aside, and then work out the big pink one as if it was a hole. And don't take the hole. We've got to remove the middle one from that. So I suggest we're going to work out the big circle. All right, I'll say area of big circle. And we're going to use pi r squared. Are you happy with that?
Yes.
Okay. And they say use 3,142. So I'm going to change pi to 3,142. That'll give us the pink circle as if the whole thing was pink. And then we're going to work out the area of the small inside because that mustn't come with. That has got to be left behind. You happy with that, Khabo?
Yeah.
All right. So we're going to do two calculations here. Do the big one and then do the small one. All right. So I'm going to quickly do these. Now, what is the radius of the big one?
It's 0.5 of the big one. Oh,
Yeah.
sorry.
So it's as if we're going from the middle all the way to the edge. So from this middle all the way to the edge.
So isn't it 1 plus 0.8?
We're close. So if I take it from this middle here, I'm only going there. So this part over here is half of the 1 meter because the 1 meter is the diameter. So we don't want the whole 1 meter. We just want the radius. We just want this little piece over there. So that's going to be half of a meter. So it's going to be 0.5. And then the last piece, like you said here, is 0.8. So I've got two pieces. I've got half of the meter in the middle. And then I've got this little piece here, which is 0.8. So that gives me 1.3. So the radius is 1.3 meters. All right. And this must be squared. Okay. And the small one, Khabo, what is the radius for the small one?
0.5.
Yeah, very good. So the small one is 0.5. So we've got 3,142 times 0.5. Whoopsie, meters. I need that to be squared. Okay. So let's do the top one first. So 3.142 times 1.3 squared gives me 5,30998. 5,30998 meters squared. And the small one, I just need to change, whoopsie, the small one just needs to change to 0.5. That's what needs to change there. 0.7855. 0.7855 meters squared. Okay, so now this top number is for a whole circle, the big one, as if there wasn't a hole, and the small one at the bottom is for the little part in the middle. Okay, so what we got to do is we got to take this little one and cut it out of the big one. All right, and that'll give us that pink shape there. You happy with that?
Yeah, so you're gonna minus the small circle from the big circle.
So the area of the big one minus the area of the small one. Stay with me, guys. Okay. So I'm just going to write the answer here now. I'm not going to write the whole thing out because we're running out of time. So 5.30998 minus 0.7855. Okay, so 4,52448. 4,52448. I'm keeping decimals, guys, until the end. All right. So this 4,52448 is now the pink shape. It was a big circle minus the hole in the middle. We don't want the hole in the middle. We just want to know what the pink part is. So we take a whole circle and we take away the hole in the middle. That's left us with that pink part at the top there. Okay. All right. Now what do I do?
You're gonna minus the
Yes.
total of the area of the big circle and small circle from the area of the wood, the square.
Very good. So we're going to take the square. We're going to minus that funny donut shape. I'll call it a donut shape. So the square is 7.29 meters squared, and we're going to minus this one here. All right, we're going to minus that, and I don't think we're going to get what they've got, but we're going to get something. So 7.29 minus 4.5. 7.29 minus 4.5244. 8. All right, 2.76552. So it's close. 2.76552 meters squared, which we can round off to 2.77 meters squared. All right, so they said when you cut away this pink donut shape out of this square wood, you'll be left with 2.01, and we're saying no, you're actually going to be left with 2.77. So it's not valid. It's not true. All right.